Welcome students, welcome to expert tutorial once again. So today we will discuss a very important topic of applied physics 2 for your upcoming semester examination, that is X-ray. So X-ray, it was discovered by a German scientist William Röntgen. Basically he was performing some experiment with a discharge tube. So what is X-ray? Basically X-ray is an electromagnetic radiation with a very short wavelength and very high energy. So as I told you earlier that X-rays was discovered by Röntgen. Now I will discuss about the properties of the X-ray, some important properties of the X-rays. Now it is of a very shorter wavelength of the electromagnetic spectrum. So X-rays, its wavelength ranges from 0.1 angstrom to 100 angstrom. This is very important, and frequency is ranging from 10 to the power 16 Hz to 10 to the power 18 Hz. Now another important properties, there are two types of X-rays we can see. One is soft X-ray and another one is hard X-ray. So soft X-rays have greater wavelength and lower frequency. Please remember soft X-rays have lower frequencies and hard X-rays have higher frequencies. And also it requires high voltage to produce. X-rays can affect the photographic plates, so they are used to capture the human skeleton defects. They travel in a straight line and do not carry an electrical charge with them. They are capable of traveling in vacuum. It can ionize gases. X-rays do not get deflected by electric and magnetic field. This is very important. Please remember this one, that X-rays do not get deflected by electric and magnetic field. Sometimes there are short questions from this one, so please remember this one. Now coming about the X-ray uses. So as we all know that it can be used in different fields. So some uses of X-rays are given below, that is medical science. There are huge use of the X-rays in the medical science, in the security system, in the astronomy uses, in the industry uses, as we use X-ray to detect cracks and air bubbles in the buildings and bridges, so and also in the detective departments. So it is also important for your upcoming exam, the use of X-rays. Now coming to the production of X-rays. So X-ray production can be done with a special type of instrument that is known as the Coolidge tube, and it was designed by the American scientist William Coolidge. So specially here you can see that there is some this is known as the cathode, and basically it is a tungsten filament. So when current passes through the filament, it gets hot and emits electron. You can see that this cathode emits electrons, and the emitted electrons are accelerated by applying a high positive potential towards the target. So this is the target material D, and the melting point of the target material should be high. Okay, and due to the sudden deceleration of fast moving electrons when they collide and interact with the target anode, X-rays are produced. So in this process of deceleration, more than 99% of the electron energy is converted into heat, and only less than 1 or 2% of energy is converted into the X-rays. Okay, so this is some points about the production of X-rays. And now coming to the Xray spectrum. Now what is Xray spectrum? So X-ray tube produces X-rays of different wavelengths, and the variation of intensity of the emitted X-rays with this wavelength is known as the X-ray spectrum. So, there are two types of distinct X-ray spectra. One is continuous X-ray spectra and another one is characteristic X-ray spectra. So, continuous X-ray spectra basically it consists of radiations of all possible wavelengths within a definite wavelength range starting from a certain minimum wavelength. So, this is known as the continuous X-ray spectra, and please remember that the minimum wavelength, as I told you, this minimum wavelength solely depends on the anode voltage and nothing else. It does not depend on the nature of the target material. So, the minimum wavelength depends on the anode voltage, and if V is the potential difference between the anode and the cathode, then the relation between the minimum wavelength and the V, that is the potential difference, will be EV equals to H nu maximum, or if we put the values of C, that is velocity of light, equals to C equals to nu lambda, and if we use this equation, then we will get this equation, that is EV equals to HC by lambda minimum, and the lambda minimum, the value of the lambda minimum becomes HC by EV, where H is the Planck's constant, C is the velocity of light, and E the charge of the electron. So, all these are constant part and it has some definite values. So, the value of E, that is the electronic charge, is 1.6 into 10 to the power minus 19 coulomb, and this H, that is the Planck's constant, its value is 6.67 6.6 into 10 to the power minus 34 joule second, and C is the velocity of light, 3 into 10 to the power 8 meter per second. So, if we put all these values in this equation, that is lambda minimum equals to HC by EV, then you can get the value lambda minimum equals to 12400 by V angstrom. So, you can put directly the value of the anode voltage to get the value of lambda minimum, that is the minimum wavelength. So, you can use this equation lambda minimum equals to 12400 by V angstrom. Now, this is a simple equation, that is how much potential is to be applied on the X-ray tube so that minimum wavelength of emitted X-ray may be 1 angstrom. So, let the required voltage be V volt. So, let the required voltage be V volt. So, you can use the equation lambda minimum equals to HC by EV, or you may use this equation equals to 12400 by V angstrom. So, here this lambda minimum is 1 angstrom. So, put lambda minimum equals to 1 and the required answer by V. So, V equals to 12400 volt or 1 to 12.4 kilovolt. So, this type of equation is very important for your upcoming exam. So this is very simple equation. So this is the graph of continuous spectrum. As you can see that it consists of the radiations of all possible wavelengths within a definite wavelength range starting from a certain minimum wavelength, that is known as the minimum wavelength. So here you can see that as I am changing the tube voltage, that is 20 kV, 30 kV, 40 kV, 50 kV, etc. So the minimum wavelength also changes. So this is all about the continuous spectrum. Please practice it carefully as it is very important topic for your upcoming semester exam. Now coming to the another Xray spectra, that is known as the characteristic Xray spectra. So you can see that it consists of some sharp intense peaks that is superimposed on the continuous Xray spectra. So this is basically the continuous Xray spectra, and these peaks are superimposed on this Xray spectra, and these peaks are named as K alpha, K beta, and L alpha, L beta, L gamma. So this continuous spectra, it solely depends on the nature of the target material. So please go through this material carefully as these topics are very important for your semester examination. So please practice this as much as possible. Thank you everybody.